Lecture 5 in the Principles of Cardiac Sonography 1 unit is Cardiac Anatomy. The contents of this lecture are 1. An introduction, wherein the aims and learning outcomes of this lecture will be introduced. 2. Pericardium, inferior and superior vena cava. 3. Anatomy of the cardiac chambers. 4. Anatomy of the cardiac valves. And 5. The great arteries and cardiac vasculature. Learning outcomes. In-depth knowledge of cardiac anatomy is essential for cardiac sonographers. It informs every scan we do. One of the aims of the course is to help you to develop that in-depth knowledge and to apply that in-depth knowledge of cardiac anatomy. So this lecture is very important and very much related to the first of the course learning outcomes. And following this lecture, so learning outcomes specific to this lecture, you will be able to define the relational and surface anatomy of the heart, characterize the macro anatomy of the heart, describe the vascular anatomy of the heart, and relate essential anatomical features of the great vessels. The textbook I encourage you to read and read carefully is the Handbook of Cardiac Anatomy, Physiology and Devices. Chapter 5, Anatomy of the Human Heart. Chapter 7, Features of the Cardiac Valves. And Chapter 8, Coronary Vasculature, are the 3 chapters of the textbook I recommend that you read most carefully. Introduction and Surface Anatomy. The heart is located in the chest. More specifically, the heart is located in the thorax, behind the sternum. Even more specifically, the heart lies within the middle mediastinum. Within the mediastinum, the heart lies at an oblique angle. That is to say, it's not straight up and down. The apex of the heart points leftward. This has some advantages when imaging the heart with ultrasound, because oftentimes there's a rib space that can be used on the left-hand side to direct the ultrasound beam towards the heart. Other important structures near the heart, of course, are the right and left lungs, and they can at times make imaging a little bit more difficult. 2 important reference points: the base of the heart. The base of the heart is at about the level of the 3rd rib, whereas the apex of the heart is at approximately the level of the 5th or 6th rib space. This information is important too when choosing in particular parasternal and apical windows with which to image the heart. That's why that oftentimes from the parasternal view one tries to find the 3rd or 4th intercostal space, and when imaging from the apical view, the 5th or 6th intercostal space. Size and shape of the heart. The heart is somewhat pine cone shaped. That is to say, it's broad at the base and narrow at the apex. and its size, generally speaking, is about the size of a clenched fist. This of course differs for females and for males. A male's heart generally, in keeping with other organs and anatomy, is a little bit larger and heavier. And the size of the heart also is influenced by disease. Generally speaking, with disease, the heart typically gets bigger. The anatomy and function of the heart, related of course to the anatomy, is both simple and complex. That sounds contradictory, so let me briefly explain. The primary function of the heart is simple, that is, receives blood from the body, and the right side of the heart pumps blood to the lungs, receives blood from the lungs as well, and the left side of the heart pumps blood around the body. The anatomy of the heart also at first glance looks somewhat simple. One initially appreciates the significant muscle mass and some of the vessels, but as one increases or looks further into things, one realizes that there's lots of specialized parts within the heart. For example, the ventricles. They have a considerable muscle mass, and in particular the left ventricle. Of course, this is related to its important function. It needs to generate significant pressure with which to support the systemic circulation. The heart valves, we'll talk about them shortly. Their function is to help ensure forward movement of the blood at all times. And when one looks at the valves, one notices that their anatomy is very detailed as well. Of course, the heart needs blood flow itself, and so there are coronary arteries and veins that supply and drain the heart. We'll be concentrating mainly on the macroanatomy of the heart. Of course, with increasing detail, one can look at microscopic structures, at the filaments, for example, within the myocytes, which comprise the heart muscle. But as I said, we'll be looking at the macroanatomy of the heart, that is to say what's visible to the eye, and really what's visible with ultrasound. So that's what we're going to be concentrating on. Pericardium, superior and inferior vena cava. The pericardium. Pericardium means around the heart. Peri, around, cardium, the heart. The pericardium covers the heart and the roots of the great vessels. That's an important detail. That is to say, it only covers the roots of the great vessels. It doesn't cover the great vessels entirely. The pericardium holds the heart in position. Its outer layer is attached to a number of other structures, such as the sternum and the diaphragm. The pericardium allows the heart to expand and fill with blood. Importantly, if that function is impaired, compromised due to disease, it can be very serious if the heart can't fill with blood. Pericardium has two distinct layers, the outer fibrous layer and the inner serous layer. The outer fibrous layer is made of tough connective tissue that helps to protect it, and as I mentioned, holds the heart in position. The inner serous layer or layers has two parts. The parietal pericardium, which is the outer serous layer, and it is fused to the inner fibrous pericardium. It also has a visceral layer, and this inner layer is fused to the heart, where it forms the epicardium. So it is in between the serous pericardial layers that there's a pericardial cavity, and within this there is the lubricating serous fluid, which helps the heart, importantly helps the heart to move and fill and contract. The superior vena cava, SVC. It's formed by the confluence, means the coming together of the right and left brachiocephalic veins from above and from the azygous vein from behind and below. They come together, as I said, to form the SVC, and the SVC empties into the superior right atrium. Of note, it's often difficult with transthoracic echocardiography to image the superior vena cava really well. Oftentimes the only view is the subcostal view. So the SVC needs to be seen well. Oftentimes a transesophageal echocardiogram is used. The inferior vena cava, IVC, which with transthoracic ultrasound is typically more easy to image. The IVC passes up through the diaphragm from the abdomen into the thorax. And it empties into the inferior right atrium. It's protected at its opening by the eustachian valve. Cardiac chambers. Firstly, the atria. The heart has 4 chambers, 2 atria, one on the right, one on the left, which are superior to the 2 ventricles, one on the right and one on the left. The atria receive blood that is returning to the heart from the right and left-sided veins. And the interatrial septum separates the 2 atria. The right atrium. As the name suggests, the right atrium is on the right side. It's superior to the right ventricle. The right atrium receives blood from the SVC and IVC, which we've spoken about, and from the coronary sinus also. The coronary sinus returns blood to the right atrium, blood that has nourished the heart muscle itself. The right atrium has a rough and trabeculated anterior wall, and its appendage inside is rough also. In contrast, it has a smooth posterior wall. The rough and smooth walls are separated by a structure called the cresta terminalis. The left atrium. The left atrium is on the left side, superior to the left ventricle, and it receives blood from the 4 pulmonary veins. We will talk about the pulmonary veins just a little bit later. The left atrium is entirely smooth within, except for its appendage. Within the appendage there are rough trabeculations. This is an important structure often, especially in certain disease settings, such as arrhythmias like atrial fibrillation, when it's important with ultrasound to see within the appendage for any potential blood clots. While the left atrial appendage can be seen with transthoracic echocardiography, most often and almost always, if this is suspected, that is, in the case of atrial fibrillation, if a clot is suspected, a transesophageal echocardiogram is indicated. Next, the ventricles. Ventricles receive blood from the atria. The right ventricle is more anterior than left ventricle. The lower image here, which is a cross-sectional or transverse image, as if viewed from below, shows that the top of the image near the sternum is the right ventricle, certainly closer to the sternum, which is anterior, than the left ventricle. Some general information about the ventricles. Their walls are significantly thicker than the atrial walls, as we mentioned, and this helps to enable them to generate the high pressures that are needed to pump blood from the heart. Both ventricles are composed of 3 layers. The outermost layer of the ventricles is the epicardium, which is the visceral epicardium. The majority of the ventricular wall is composed of myocardium, which is the middle muscular layer, whereas the innermost layer is endocardium, a layer of simple squamous endothelium which serves to prevent blood from clotting and adhering to the inner layer of the heart. Some other general information. This time about the geometry of the myofibrils, that is the fibers that comprise the muscular walls. The myocardium, which just mentioned is the majority of the heart wall, the fibers within it are arranged in different orientations. The predominant orientation is circumferential fibers, especially in the mid and outer walls. The inner walls of the myocardium tend to have fibers that are arranged longitudinally, so that is to say a more vertical type orientation, like the image on the lower right displays. So the right ventricle. The right ventricle, as we said, is the most anterior of the ventricles and in fact the most anterior cardiac chamber, and sits immediately behind the sternum. Compared to the left ventricle, it's more triangular in shape. It curves around and almost hugs, you would say, the left ventricle. The right ventricle has more coarse trabeculations than the left ventricle, and it also has a very prominent moderator band towards its apex. The right ventricle has 3 general areas within, which are termed the inlet, trabecular, and outlet portions. The left ventricle, which is posterior to the right ventricle. The left ventricle is more cone-shaped, and the left ventricle forms the apex of the heart. Its cone shape promotes flow in and out in a vorticular manner. That is to say, the shape supports the mechanical action of the heart so that the blood forms vortices which have a certain momentum and help the movement of blood. The left ventricle has fine trabeculations in contrast to the right ventricle, which has rough trabeculations. Distinct from the fine trabeculations in the left ventricle are two prominent papillary muscles, the anterior and posterior papillary muscles. Generally speaking, the left ventricle has three parts: basal, mid and apical portions. The basal being uppermost, the mid and then the apex towards the ventricle's apex. Of course, this image that you see here is how they would normally appear in an echocardiogram, where the apex is actually inverted and appears at the top of the sector. The ventricular septum is said to belong to the left ventricle, not the right. So the ventricular septum, strictly speaking, is part of the left ventricle. And this slide helps to reaffirm some of the other anatomical differences. Its shape. In cross-section it is very round, and much of this has to do with the fact that the pressure within the left ventricle, particularly in systole, is greater than pressure within the right. It has thicker walls than the right ventricle. Certainly that's the case normally. It has prominent papillary muscles, whereas the right ventricle, as we mentioned, towards its apex, has the moderator band. Cardiac valves. There are 4 heart valves: 2 atrioventricular valves that separate the atria and ventricles, and 2 semilunar valves that separate the ventricles and great arteries. Firstly, the atrioventricular valves, the left-sided AV valve, the mitral valve. The mitral valve is a relatively complex structure with 5 components. The fibrous annulus, the structure from where the leaflets hinge, the leaflets themselves, and commissures where the leaflets separate, the chordae tendineae and papillary muscles inferior to the valve leaflets, and these importantly, the chordae and papillary muscles, anchor the leaflets and limit their amount of motion, particularly when the ventricles contract. The 2 leaflets are the anterior and posterior leaflets. The anterior mitral leaflet is more trapezoidal in shape. In contrast, the posterior leaflet is more elliptical or crescent shaped. The tricuspid valve is somewhat similar to the mitral valve, although it has a different number of leaflets. But it also has 5 components. It has a fibrous annulus from where the leaflets hinge. It has leaflets and commissures, chordae tendineae and papillary muscles. Its 3 leaflets are anterior, septal and posterior leaflets. The first of the semilunar valves is the aortic valve. The 2 semilunar valves are more simple in their structure than the atrioventricular valves. They have three components. The left-sided semilunar valve, the aortic valve, is importantly the most central heart valve. The aortic valve has three components. The fibrous annulus, the hinge point for the leaflets, or cusps. The leaflets themselves, which are oftentimes termed cusps, and the commissures. And on the image on the right there, you'll see three arrows pointing to the commissures, the points separation of the cusps. The three aortic valve leaflets are named according to the coronary artery superior to them. That is to say, just superior to the cusps are three sinuses, and from two of those sinuses arise coronary arteries. So, above the left coronary cusp is the left sinus, and from this is the opening, the ostia of the left coronary artery. Above the right coronary cusp is the opening to the right coronary artery. And as the name suggests, above the non-coronary cusp there is a sinus, but no coronary ostia, no coronary artery, hence the name non-coronary cusp. The pulmonary valve is the other semilunar valve, and like the aortic valve, the pulmonary valve is a simple structure with three components. The pulmonary valve is the most anterior of the four heart valves. It has an annulus, the hinge point for the leaflets themselves and commissures. It has three leaflets, and they do not have coronaries above them, obviously. They're named rather in terms of their anatomical position. So the leaflets are named anterior, left, and right. The great vessels and cardiac vasculature. Starting on the right side of the heart. The main pulmonary artery ascends at an oblique angle from the heart, at an angle somewhat leftward, and as it ascends anterior to the aorta, remembering of course that the pulmonary valve from which it ascends is the most anterior of the heart valves. As the main pulmonary artery ascends, it exits the pericardium and then branches into the right and left pulmonary arteries. The right and left pulmonary arteries branch further once they enter the hilum of the lungs. Blood within these vessels enters the lungs to be oxygenated and then returns to the heart. Via pulmonary veins. There are two pulmonary veins, upper and lower, from each lung. So in total there are four. The right upper and lower veins enter the posterior left atrium from the right. The left upper and lower veins enter the posterior left atrium from the left. These illustrations help to show that, and the right one shows the right upper pulmonary vein imaged using colour Doppler from a transthoracic echo. On the left side, the ascending aorta. It starts at the aortic valve, the most central of the heart valves, and ascends from the pericardium posterior to the pulmonary artery, posterior to the pulmonary artery. The ascending aorta consists of sinus and tubular portions. The sinuses are 3 pouches, and the left and right pouches, left and right sinuses, give rise to the left and right coronary arteries. The tubular portion, which is superior to the sinuses, ascends posterior to the pulmonary artery. The aorta has an arch, and it arches posteriorly from the right to left, passing over the right pulmonary artery, and then descends posterior to the left pulmonary artery. At its arch, the aorta gives 3 branches. The right brachiocephalic trunk, which then branches into the right common carotid and right subclavian, the left common carotid, the left subclavian, left subclavian. The aorta descends then through the thorax and into the abdomen. Let's briefly look at things at the vessels and the chambers and the structures that we've looked at so far, as though we were following the passage of blood through them. Blood by the superior and inferior vena cava enters the heart, enters the right atrium. The inferior margins of the right atrium is the tricuspid valve with its 3 leaflets. Through the tricuspid valve, blood then passes into the right ventricle. The right ventricle, which is trabeculated and has inlet, trabecular, and outlet portions. Blood via the outlet portion travels through the pulmonary valve, the semilunar pulmonary valve, and up into the main pulmonary artery, which is the most anterior of the 2 great arteries. Blood then, as the pulmonary artery branches to left and right-sided branches, can travel into the lungs to be oxygenated. Oxygenated blood then returns to the heart via pulmonary veins, upper and lower pulmonary veins from both the left and right side, and into the left atrium. At its inferior margin is the mitral valve, the atrioventricular valve, the unique mitral valve in that it's only got 2 leaflets, which is distinct from the other valves. As pressure builds within the left atrium, the mitral valve opens and blood enters the left ventricle, the canonical and muscular left ventricle, which then pumps blood through the left-sided semilunar valve, the aortic valve. Through the aortic valve, blood passes up into the aorta. Of course, to function properly, to function at all, the heart needs its own blood supply, and this is achieved via the coronary arteries, and there are 2 main coronary arteries. The right coronary artery has its origin in the ostia of the right sinus of valsalva, so that's the pouch, the right side of the aorta, just superior to the aortic valve. This right coronary artery has 2 main branches that supply predominantly the right side of the heart. These are the marginal and posterior interventricular arteries. And on the left coronary artery, which has its origin, its ostia, in the left sinus of valsalva, just superior to the left coronary cusp of the aortic valve. Its main branches are the left anterior descending and circumflex coronary arteries. This CT image shows the two coronaries, left and right, and some of the branches. The front of this image is the left main coronary artery and its branches, the left anterior descending, which descends almost vertically down to the apex of the left ventricle, and then the circumflex, which wraps somewhat around the posterior margin of the left ventricle. Behind, one can see the right coronary artery as well, and oftentimes the right coronary is dominant. It is the biggest vessel, somewhat obscured by the aortic, the aorta, the sinus portion of the aorta there, but it can be appreciated, the back of this image. Of course, there need to be veins to drain the heart as well. The venous drainage of the heart is accomplished by three systems. Most significantly, the coronary sinus, and most veins drain into this. And the coronary sinus itself empties into the inferior right atrium, and the thespian valve is at the entry point, which is in the inferior margin of the right atrium. It's the thespian valve which prevents backflow. There are two other systems also. There are anterior cardiac veins which don't drain into the coronary sinus, and thespian veins as well, which are valveless communications from myocardial capillaries into all four chambers. So we've considered a number of things, and as I said at the start, this is core knowledge related to one of the key course learning outcomes. This lecture is part of your development of in-depth knowledge of cardiac anatomy. I hope you appreciate more fully now the relational and surface anatomy of the heart, and are better able to define the macro anatomy of the heart, to describe the vascular anatomy of the heart, and relate essential anatomical features of the great vessels. Of course, applying this knowledge when imaging is important, and I strongly encourage you to try and apply that knowledge as you begin to understand images and their views more fully. Obviously, because predominantly we use 2D imaging, and this, in a sense, slices through the heart, is unable to give a complete picture of the heart, but those slices obviously enable one to see many structures in each view or each projection. One can see, of course, chambers, margins, the walls of chambers. One can see arteries. One can see valves. One can see each of the valve leaflets. One can see the subvalvular apparatus. Many different things. This will be covered in a tutorial as well, where we'll start considering anatomy from that more practical point of view, that is, the anatomy that can be seen in the different views of the heart as imaged using the transthoracic echocardiography.